Now let us solve exercise 10 together now. We have that three towns A, B, and C are situated such that AB is 60 kilometers, AC is 100 kilometers. The bearing of B from A is 60 degrees and the bearing of C from A is 290 degrees. The first thing we do is to represent this in a diagram. So let's assume we have A here, north, south, east, and west. Now this is point A, and such that the bearing of B from A is 60 degrees. So we have 60 degrees, which is less than 90 degrees. Yeah. This is the bearing of C from A. And this is for 60 kilometers. So when we get here, we draw another cardinal point of north, south, east, and west. So this is point B. And the distance of AB is 60 kilometers. Moving on, the bearing of C from A is 290 degrees. So we are saying the bearing from this point to this point is 290 degrees. So the distance moves in this direction from here to here at an angle of 290 degrees, a length of 100 kilometers. So when we get here, we draw another cardinal point of north, south, east, and west. So there, after that, we then draw the connecting points between B and C, because this point is C. And let's draw the connecting points together, and we have this. Now let's simplify this diagram now. If this is 290 degrees, then the remaining angle here will be 360 minus 290 degrees, because the total angle at the point is 360 degrees, and 360 minus 290 is equals to 70 degrees. So the total angles between this total angle here, we call it 70 plus 60 degrees, 70 degrees plus 60 degrees, which will be equals to 130 degrees. Now we have 70 degrees and we have 60 degrees, which is equals to 130 degrees. Definitely we can resolve this diagram in this manner, such that we have a point A to B is equals to 60 kilometers, A to C is equals to 100 kilometers. The angles between AB and AC is 130 degrees. And we are asked to find the distance BC and the bearing of B to C. So let's begin with the distance BC. Let's call it X. Okay, or for more ease, we say X is equals to A, just like in cosine rule. B, this is equals to B, and 60 kilometers is equals to A. So applying cosine rule now, we have that C squared is equals to A squared plus B squared minus 2AB cos C. Therefore C, which is equals to, okay, we are looking for A in this case. So we have A squared is equals to B squared plus C squared minus 2BC cos A. In this case, A is equals to X, so we have X squared. B is equals to 100 squared. C is equals to 60. C is equals to 60. We have 60 squared minus 2 into 60 into 100 multiplied by cos 130 degrees. So simplifying further, this will give us 1,000, 10,000 plus 36,000, or no, 3,600 plus 12,000. Cos 130 degrees is similar to cos 50 degrees. or for more explanation, because 130 degrees is equals to negative, and this will still be negative. So simplifying further, so we'll have 13,600 minus 12,000 multiplied by cos 50 degrees, which is 0.6428. So we'll simplify and we'll have x squared to be equals to 21,313.6, and we will find x by taking the square root of these. Then we'll have x to be equals to approximately the square root of 21,313.6. we'll have it to be 145.99 kilometers, which is approximately 146 kilometers. So we have solved the first question. So say it's find the distance BC. So distance BC, which is x, we solved it using cosine rule. Now the next point of action now is to evaluate the bearing of B from C. What does it mean, the bearing of B from C? So that means our focus is C. So if we come to C now, if you look at this, we will have an angle here. We can also have an angle here, likewise an angle in this direction. If we look at this analogy now, if this is 20 degrees, what we paused earlier on, this is 20 degrees, this is 70 degrees. You can come to terms that this angle here at this point is 70 degrees. Then the bearing that we are looking for is the angle from the north 0 degrees passing through the east. So what we are looking for now, what we should focus on, is to look at the angle at point C. Let's look at for the angle at point C. Let's draw the diagram again, or let's just duplicate it. Duplicate, and we come down here. So let's evaluate angle at point C. So therefore we'll be using sine rule, and in sine rule we understand the concept that A divided by sine A is equals to B divided by sine B, which is equals to C divided by sine C. So in that case, we are looking for C, angle C, and we have length C. Likewise, we have length A, angle A, but we do not have angle B. So let's use A divided by sine A is equals to C divided by sine C to evaluate angle C. So moving on, our A that we evaluated to be x is 146. Our angle A is sine 130 degrees. Then length C is 60, and we are looking for angle C. So making sine C solve the formula, we have that sine C is equals to 60 multiplied by sine 130 degrees divided by 146. Sine 130 degrees can be also be written at 60 multiplied by sine 50 degrees, because 130 degrees falls in the second quadrant, first quadrant, second quadrant, third quadrant, and fourth quadrant. 130 degrees falls here, and here it is the acute angle is 180 minus theta. This we did in our early stages of trigonometry, and sine is positive here. All others are negative. All is positive here, only tan is positive in the third quadrant, and cosine is positive in the fourth quadrant. So we'll have it to give us 60 multiplied by sine 50 degrees divided by 146. So using our calculator, straightforward, we have 60 multiplied by sine 50 divided by 146. So we'll have that sine C is equals to 0.3148. 0.3148. So we can evaluate our angle C to be arc sine of 0.3148. So this will be equals to 18.35 degrees. So we have angle C now to be 18.35 degrees. But the question we are asked is to evaluate the bearing of B from C. Remember, we have angles 18.35 degrees. Now, let's go backwards now to analyze the question. We have point A, point B, and likewise point C. Point A to point B has this angle of 130 degrees, the length of 60 kilometers, likewise length of 100 kilometers, and we evaluated this length to be 146 kilometers. And now we just evaluated that the angle is 18.35 degrees. Now, to evaluate the angle properly, let us duplicate what we have here so that we can use it for our analysis to get the bearing. So duplicate, and then we'll finalize the diagrams. Okay, we are almost there, and now we are there. Now we have evaluated X to give us 146 kilometers. We know the angle at point A is equals to 130 degrees. This is point A. The angle here is 130 degrees. Similarly, the angle at point C, this angle here, is equals to 13, or rather 18.35 degrees. Now the question is, we are looking for this angle from the north down to the position of this line, and we are found by corresponding angles. That's 70 degrees, which is the angle that we got from 290 degrees, is the same angle here. So if you redraw this concept at point C again, let's draw it out again for more visibility. We will have north to the south, to the east, to the west. So we have this length coming from point A, and we have this length, this line going to point B. This is point C. The angle from here that we evaluated is 18.35 degrees, and we are looking for the angle here. Let's call it X. Now, according to geometry, we have that the angle represented here is 70 degrees. So now we can have the angle on a straight line. So we know that the sum of angles on a straight line is equals to 180 degrees. So let's apply that now so that we're able to get the bearing of B from C. So let's apply this concept and say that using the angles on a straight line, we have that 70 degrees plus X plus 18.35 degrees is equals to 180 degrees. This is called the sum of angles in a straight line. So moving further, we can now evaluate X. So we have X is equals to 180 degrees minus 70 degrees minus 18.35 degrees. And if we use our calculator here, we have that the bearing X is equals to 91.65 degrees. So the true bearing of B from C is 091.65 degrees, and the distance of B from C is 146 kilometers. So we have seen now how to apply trigonometry to both navigation and bearing.